Hi, ladies and gentlemen. I just want to go over a couple of examples with you guys because I know that this can be, it can be tough to learn a new topic over distance learning. Up to this point, we'd kind of seen, for the most part, topics that we had seen before, whether it was 3D measurement in terms of volume, area of circles, converting with radius and diameter, circumference and area. That's all stuff that we've seen before. The trig ratios are really new this year. So I want to give you this opportunity to see how I handle these, and then I'd also like to host a Google Meet for extra help for anybody that might need it. So if you need it, just send me an email or start a chat with me on Google Meet, and we will set up a time so that we can go over some things if you are having any difficulty. I can pretty much do it anytime, anytime that's reasonable. Not like 10, 11 o'clock at night, but if you want to do it before class, if you want to do it during that kind of lunch break in the middle, if you needed to do it at like 3 or 4, for the most part, I'll still be available. So just shoot me an email or send me a message through Google Meet. All right, let's get started with this. So one of the most important things that we've learned is an acronym. And I'm not a big fan of acronyms when it comes to math, but I think this makes the trig ratios make a little bit more sense to us. So what we're going to do is we're going to write that down. That acronym is SOHCAHTOA. SOHCAHTOA. Now, this looks a little bit different than the other times you've seen it, and the reason I write it like this is because this is in the format of the actual ratios. So you should know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And this will help us figure out what ratio to use and which side lengths to use. In this specific example, we are given a right triangle with an angle x, and we want to know what cosine of x is. So that means we need the adjacent side and the hypotenuse. Well, the hypotenuse is always across from the right angle, so that's going to be our 13 here. This is going to be our hypotenuse. Adjacent means right next to, so the side length that is right next to our x is 12, leaving the opposite side to obviously be opposite. So if we are finding the trig ratio that represents the cosine of x here, we need adjacent over hypotenuse. We already have our values for that. That's 12 over 13. So cosine of x equals 12 over 13. And there we are. We did it. That's it. That's all you need to do for that one. For the second part, it's a little bit trickier, because we're asked for sine of x, which means we need opposite over hypotenuse. We don't know what the opposite side is, but this is right triangle, and we do have a formula, a theorem that will help us find the opposite side, and that is the Pythagorean theorem. So just a quick refresher on that. The Pythagorean theorem only works with right triangles, but it says that the length of the right triangles, if you take the two legs, square them each and add them together, so the sum of the squares of the legs would be equal to the square of the hypotenuse. We will have here, we know that we'll call the adjacent side A, the opposite side B. That doesn't really matter, but the hypotenuse must be C. So we'll say that 12 squared plus B squared is equal to 13 squared. That's just substituting in the values that we already know. 12 squared is 144, plus b squared is equal to 13 squared, which is 169. If I subtract 144 from both sides, I get b squared is equal to 25. So my next step is going to take this to take the square root of both sides, and we should know what the square root of 25 is, because it's in that first 10 to 15 range that we should be able to memorize. What times itself gives us 25? It's 5. 5 times 5 gives us 25, so b is equal to 5, meaning that the opposite side up here is 5. And this is actually a Pythagorean triple. We talked about those in class. There are some triples of numbers that will always satisfy the Pythagorean theorem. 3, 4, 5 is one of them, where 5 is the hypotenuse, and 5, 12, 13 is one of them, where 13 is the hypotenuse. So if I multiplied these all by 2, and I had a triangle that was similar, that was 10, 24, and 26, that would be a right triangle, and it would definitely follow the Pythagorean theorem, because it's all of these numbers just scaled up a little bit, they're doubled. But anyway, sine of x is opposite over the hypotenuse, which means sine of x is going to be 5 over 13. And that is our answer. So what we did there, just to kind of sum it up, for the first one, we were given all of the information. We just needed to know what the ratio was. For the second part, we did not have one of the sides for the ratio, so we needed to use the Pythagorean theorem to find that side, and then we used the ratios that we know to find out what sine of x is. Okay. For number 2, this example is a little bit different because now we are given 2 side lengths, but one of them is a variable, but we're also given of the measure of the angle that we need to actually care about, that 41 degrees there. So we are going to use that angle measure to solve for x. We're going to use that in conjunction with our trig ratios, which we know. So katoa. So right here, we're given the opposite side to 41 degrees. We know we're not given the hypotenuse because that has to be across from the right angle. But we are given the adjacent side as well. So we have opposite and adjacent. The only trig function with both of those is tangent. So we're going to say that tangent of 41 degrees, and that's going to be important in a second, is equal to the opposite side, which is 4, over the adjacent side, which is x. Now, tangent of 41 degrees is just a number. It's a ratio that when you divide it out, you get a decimal. It's just going to be a number. So we can treat it as a constant because we can put it over 1, and we'll be able to cross multiply and solve for this. So I'm just going to write this as x times tangent of 41 is equal to 4, because we did x times tangent 41, and 4 times 1 is 4. So now what we can do is we'll just divide both sides by the tangent of 41, which again is a number. So we get x equals 4 divided by tangent of 41 degrees. So we're going to go into our calculator to figure out what that is. Now, there's 2 different ways to measure angles, degrees and radians. Your calculator can handle both. We want to make sure that it's working with degrees, and that's why I said that'll be important. So if you hit the mode button, and then you go down to where it says radian or degree, go to degree and hit enter. Then, if we hit second mode to quit out of that, anything that we type in will be understood as degrees and not radians, which will give you far different answers. We might get into what radians are this year. I'm not so sure that we will. But we do want to know what 4 divided by the tangent of 41 is. And we are going to put this, our answer, to the nearest tenth. So 4.6014, we know that this 0 next to the 6 means that the 6 will not be changing, so we get 4.6 as our answer. It would be 4.6 units, but I didn't give you any units here, so we'll just leave it generic. If it was feet, then you would write feet. If it was miles, you would write miles, whatever. And that's it. So if you guys have any questions, please make sure that you're emailing me or posting them on Google Classroom. I will definitely I would definitely love to help you guys. I haven't been getting a lot of questions, which kind of concerns me. A couple of you guys have been asking questions, which is great. But I want to make sure that you guys do understand this because, especially for those of us going into Common Core Geometry next year, this is a unit that is kind of tough to fit in there, and then it can get a little difficult. So I want to make sure that you have a base or at least have seen it before you go into next year. So, so you have one more assignment through Wednesday, and that is the Alex assignment. It's 11 questions. I want to see how you're feeling with Trig before I make the decision on whether we should go on, whether we should take a step back, or whether we should just practice exactly what we've been practicing. It's a little hard for me to judge because, this is very much like you. This is my first time doing distance learning. In the classroom, I can kind of get a better sense and make that decision. But right now, I need your input and your feedback. All right. Have a great day. Thank you.